Hello world viewers, what's up? I hope all you are doing well and your nears and dears are also doing well. First of all, I convey my best regards and heartful thanks to all of you those who are watching my videos regularly. Then good morning to those who are watching my videos in the morning, and good evening to those who are watching my videos in the evening, and good night to those who are watching me in the videos in the night. The wishes are completed, right? So in previous video we have discussed about the relative mass derivation, right? What is the formula? That is m is equal to m naught upon 1 minus b square upon c square. We derived that in the previous lectures. If you have not watched that, then go and watch that. And if you remember, I use a formula in separate on that. The additional formula is that the velocity addition theorem. I use a formula. If you remember that, then I will write it again, that u is equal to u dash plus b upon 1 plus u dash b upon c square. This is the velocity addition theorem I used in relative mass equation when the derivations happened in the previous video, right? So in this video I am going to derive this. So before deriving this, what is the application of this theorem? I just want to tell you. You can find that the application happened when we derive the relative mass equation applied on that. And what is the another application of this equation? And the another application of this equation is to identify the second postulates of Einstein, that is the constancy of the speed of the light. The constancy of the speed of the light. We'll look it in the last of this video, right? How it helps to identify the speed of the light never be any kind of relative, it is always absolute, right? We will see it in the last of the stage, right? Before this we have to derive. So before derive this, we have to take the consideration. What we have took the consideration in the previous, that there is two frames. There is a S frame and there is a S dash frame. There is a S frame, right? This is the X, Y axis and the Z axis. Here the observer is Sudipta. He is sitting here. He is in the stationary frame. Okay. In the same time, there is another frame. This is the S frame. This is the S dash frame. Here who is sitting? Here Einstein is sitting. He is moving in a constant velocity, that is v velocity. Okay, he is moving a constant velocity, that is v velocity. You say that what are the difference in the consideration of that and this? There is no difference. There is no big difference between the considerations here, right? Here are also the same consideration. The two frames are here, the S frame and the S dash frame. But what are the extra consideration here? Here there is a particle is moving. There is a particle is moving. Let's say there is a p particle is moving with something velocity. Okay, with something velocity. So what is the scenario for this? O dash, this is the X dash, this is the Y dash, this is the Z dash. What is the scenario for this? The particle has a particular velocity. It is moving in a particular velocity and the frame is also moving a particular velocity, right? And from me, the particle's velocity what? For Einstein, the particle velocity for what? Right? So for me, what is the velocity of that particle? And for Einstein, what is the velocity of that particle? So we have to discuss here about those kind of things, right? So before discussing about this, let's say its velocity is u. Let's say its velocity is u, simply u. Okay. We know there is a relation, that the displacement and velocity relation. The velocity is known as the rate of change of the displacement. Okay, we can say if the component of the x-axis, if you take the ux is equal to dx upon dt. X is the displacement here. According to me, the velocity, the x component of that velocity is dx upon dt. Okay, if you took the y component, that is uy is equal to dy upon dt, and the z component will be uz is equal to dz upon dt. So this is according to me. The same things we can apply here. Let's say this is the ux dash. According to Albert Einstein, what will be it? It will be dx dash upon dt dash, right? Uy dash is equal to dy dash upon dt dash, and yz dash is equal to dz dash upon dt dash. So it is according to Albert Einstein. This is according to me. Okay. Let's say ux x component and y component z component. We will see the particle is moving in the along x axis. That means there is no role of y and z axis. According like that, the Lorentz equation. There is no relation between the y and z axis because the particle is moving in the x direction, right? So we can these things are not used of us right now. So let's say this is the equation 1. ux component is equation 1 and ux dash component is equation 2. Ux dash component is equation 2. I used a word that is Lorentz transformation equation. You say Lorentz transformation equation, remember, yeah, I also derived that equations in the previous videos. If you go to that, Galilean transformation equation and Lorentz transformation equation. Lorentz transformation equation when the particle is moving in very close to the speed of the light, there Lorentz transformation happens. So we have derived the four coordinates, that's x dash, y dash, z dash and t dash. Let's say what are the Lorentz transformation. If you go to the Lorentz transformation equation, what are the four equations we have derived on that? That is x dash is equal to x minus bt upon 1 minus b square upon c square. Then t dash is equal to t minus xb upon c square upon 1 minus b square upon c square root over, here also root over. So this is the x dash and the t dash component. And I said the y dash and z dash components are not there because the particle is moving along the x axis. That's why y dash will be y and z dash will be z, right? So for this we have discussed this kind of things here. Okay, this is the x dash, this is the t dash, and this is the x dash, right? So if you took the second equation, that is ux dash is equal to dx dash upon dt dash. Okay. So we have x dash, we have x dash. What is the meaning of dx dash? Dx dash means its differentiation. Its differentiation. So we will do the differentiation. That is x dash is equal to x minus bt upon 1 minus b square upon c square root over. So we have to find what is dx dash. We have to find what is dt dash. We have x dash. Very simply we can find dx dash. How? We use differentiation. It is a basics mathematics, it is basics calculus. Okay, so how can we do it? For this we'll do simple differentiation without any with respect to component. Okay, without any independent component. So x dash will be dx dash, right? X will be dx, and b is the constant velocity. It is moving in a constant velocity. That means b will be the constant. That is b dt. And 1 minus b square upon c square is always a constant. B is constant, c is constant. So it will be 1 minus b square upon c square root over, right? This is our dx dash. This is our dx dash. Like that. What is t dash? T dash is equal to t minus xb upon c square upon 1 minus b square upon c square root over. We have to find what is dt dash. We have to find what is dt dash. That means dt dash is equal to t will be dt minus x will be b upon c square is the constant. That means x will be dx, and it is the constant 1 minus b square upon c square root over. So we have dx dash, we have dt dash. We have dx dash, we have dt dash. What does it mean? We have find what is ux dash. Very simply, we can find ux dash. Ux dash is equal to dx dash upon dt dash. So dx dash is equal to dx minus b dt, dx minus b dt upon 1 minus b square upon c square root over. Then what is dt dash? Dt dash is equal to dt minus b upon c square dx upon 1 minus b square upon c square root over. So denominator and denominator both are equal. So it will be cancelled out from upside down. That means it will have dx minus b dt upon dt minus b upon c square dx, that is equal to ux dash. Okay, we have find ux dash. What is ux dash? We have found here. So what is we have to do in the next? We have to do some relations between ux dash and ux. We have to find some relation between ux dash and ux. So what is ux here? Ux is nothing, that is dx upon dt. So if we find any kind of dx upon dt, then we can easily find the relation between ux dash and ux. So we have to settings these kind of things by which we can get dx upon dt. So how can we get it? Just take the common dt from both sides. Dt from both sides. What will happen if we took the dt common here? What will happen here? Dx upon dt minus, if dt will be common, that it will be only v upon, if we took dt common, then it will 1 minus what will have? V upon c square dx upon dt, dx upon dt. Okay, we have found here right now. that is dt will be cancelled out, it is on the upside and downside. So dx upon dt is ux minus b upon 1 minus b upon c square ux, that is ux dash. So I can see some relation between ux dash and this, right? So it is very fantastic point for us here, because from this to this we have found these kind of things, right? So what we have to derive, I just want to write the m, that is u is equal to u dash plus b upon 1 plus u dash b upon c square. Okay, I just erase this kind of scenarios here. I just erase. Don't worry, these are not required now. In the notes section, I tell you that I have made a WhatsApp channel. I urge everyone to join on that channel, by which I can provide the materials. Materials are ready with me. Why I not uploaded? Because the crowd is not there. If I upload now and someone is after join, then that material will be vanished for him, right? So it is your responsibility, you can say. I can say it is my urge to you that you should join that WhatsApp channel, right? I'll give that description in the link or in the comment section on the top. I will pin that comment. Okay. So here, what I will say, that ux dash is equal to ux minus b upon 1 minus b upon c square ux. So others components are not happening here. Here the y components not happening, the z component not happening. That means we can easily say that ux dash, we can easily write u dash is equal to u minus b upon 1 minus b upon c square u. Okay, I don't write here ux. I just removed this. Why? Because y, z are not working in this. I have to derive this kind of scenarios, so I have to get this kind of scenario. That means there is no z component, y component, x component, t component. Okay, that's why I do it. Okay, here we have to just transfer this equation. Transfer this equation means when we take the inverse, what will have? The dash will be changed to normal position and the minus sign will be plus position, right? And the constant will be the same. What we have, that is u dash will be u and u will be u dash. Sign will be changed, plus b upon 1 plus bc square is constant. That means u will be u dash b upon c square. So this is our required equation, what we are looking for. Have you feel my happiness here? What I am looking for, I got it here, right? So you say, why I change the sign? Why I change the sign? It is a frame of reference. If you take, it is u dash. U dash means it is according to Albert Einstein. He is moving on that frame. He is moving on that frame. That means the particle is moving from that side, that side, that side. For him, it is going apart from that. Okay, but for me, it looks different. It looks different. The extra speed will be add on that. The particle is moving on something. For me, it will looks like it is v plus u, right? V plus u. But for Einstein, it is u minus v. That means the particle is moving in the high speed rather than the frame. For me, it is additional. For example, I am sitting on something. Let's say I am sitting on a bike and there is a bus moving inside beyond me. Okay, and in the bus there is a wall is also traveling with that. Okay, I'm forget about that. I'm sitting in the, I am no bike. Okay, I'm sitting on under a tree and the ball is moving right side here and the bus is also moving. For me, it looks like the ball speed plus the bus speed is equal to that ball speed. The same scenario here. Here I am sitting here. For me, the particle is moving plus the frame is moving. That means particle velocity plus frame velocity will be this scenario. And this is the velocity addition theorem. For derive it, we use Lorentz equation. And I have also derived it from the previous videos if you watched it. Galilean transformation equation and Lorentz transformation equation. Okay, so here there is no biggie here, no any confusion here. Very simple derivation. I have done it. Okay, so if you have any doubt, kindly ask me in the comment section. For importantly, I say if you have any kind of questions arising inside you, any kind of, you can ask me. I'll answer you definitely. I told you, but you have not asked the question. How can I answer? If there is no appetite inside you, then what is the meaning of the food? Okay, so Here one type of we can got the root system here. Then we will go to the basics as well, right? Don't worry. Still, if you have any doubt, and kindly join that WhatsApp channel. Okay, you will get those kind of notes. Okay, we got this equation. Okay, we got this equation. So after getting this, I told you that in the first stage that the application of this equation is to identify, to verify the constancy of the light, speed of the light. Constancy of the speed of light means the speed of the light is constant irrespective of your velocities are happening, the other things are happening. That is also the Michelson-Morley experiment. We will discuss another videos that Michelson-Morley experiment, but here I just use this equation to identify whether the speed of the light is constant or is velocity, it's relative. U dash plus b 1 plus u dash b upon c square. So first test I say if the frame is moving with the speed of the light. In the first state I will say if the frame is moving in the speed of the light, what will happen? Let's see. If the v is equal to c here, v is equal to c here, what will happen? Let's say v is equal to c, that means the frame is moving in the speed of the light, in the very fast speed. What will happen? U dash plus c upon 1 plus u dash c upon c square. In the v I just replace c. Okay, what will happen? That is c and c will be cancelled out, 1 c will be cancelled out, that is u dash plus c upon 1 plus u dash upon c. What will happen in the next stage? That is u dash plus c upon, if you take LCM, that is c plus u dash upon c, and this will be cancelled out and this c will be go to the upside, that means it equal to c. That is what is that reference? That u is equal to c also. That means the particle is moving in the speed of the light. There is nothing additional happening here. The second consequence I will take the second consequence that here v is c, and in the second consequence I tell u dash is c. U dash is c. It means that according to Albert Einstein, the frame is moving in the c speed. The particle is moving in the c speed. Okay. Now what will happen in the next stage? Let's say that is u is equal to u dash plus b, that means in u dash we can replace c plus b upon 1 plus, in the u dash we will replace c b upon c square, and 1 c will be cancelled out. The same scenarios will be happen. C plus b upon 1 plus b upon c. If you took the LCM, then those are to cancel out and it will be remain as c. That means here u is equal to c also happening. Here u is equal to c also happening. Then what happened here? Whatever. If the particle is moving in the speed of the light, then u is equal to c. If the particle is moving in the speed of the light, then u is equal to c. Okay. Let's say both, everything are moving in the speed of the light. What will happen on the next? We'll see it here. Okay, we'll see it here. If u dash is c and u dash is equal to c, u dash is equal to c, and b is equal to c, both are c. That is u is equal to c plus c upon 1 plus u dash b, both are c, that means c multiplied by c, that is c square upon c square, that is upon 2c upon 1 plus c square upon c square, 1, that means 2c upon 2, that's equal to c. That means here also u is equal to c. The first scenario u dash is equal to c, the second scenario u is equal to c, the third scenario u is equal to c. What happened here? That means the speed of the light is constant. Negligence in case of your metallistic values, that means c is equal to 3 raised to power 8 meter per second. Here some fluctuations are happening here in the numerical values, but it is in maximity case, speed of the light is constant. For example, a bus is moving, and there is also a light. A light is moving in the speed of the light, that is c. If you say the bus is moving in 90 km per hour, the bus is moving in 200 km per hour, it means c speed will be more here. For a simple man, if it is moving in c speed and the bus is moving in 280 km per hour, that means it will c plus 280 km per hour. Things are c plus 280 km per hour, but it will not increment the speed of the light. It is just c. C plus something is equal to c. C plus any weak thing is equal to c. That means this is defines the constancy of the speed of the light. Right? Here I conclude my video. If you have any kind of doubt, kindly ask me in the comment section. If you have any kind of questions happening inside yourself, then ask me in the comment section. I will definitely try. If you don't question me, how can I answer you? If there is no appetite inside you, what is the value of food? If there is appetite, there is a value of food, right? If there is a question, there is answer. If there is answer, there is a question. If there is nothing, there is nothing. So I request you, subscribe this channel and share this channel, and also if you like my efforts, give a thumbs up here. I do a lots of efforts for you. Anyhow, here I conclude my video by saying thanks you for watching this